Greetings to viewers and listeners. My name is Sumanata Lohara. I am pursuing my final year MCA from Railtech Multitech Engineering College. My company name is Action Technologies. Mr. New Begin is my internal guide. My project is about automatic test package generation. Now let's see about its abstract. Networks are getting larger and more complex, yet administrators rely on rudimentary tools such as ping and traceroute to debug problems. When we use the number of routing instances, we face the debugging problems. So this model is to generate a minimum set of packets to access every link in the network, maximally or minimally. This project conducts a thorough study of this new form of interconnection, which presets the condition for its correctness and optimality. This project proposes a new form of interconnection that overcomes the limitations of route election and route redistribution, which permits the configuration of a resistant and efficient routing system. So now let's see about its existing system. In existing systems, we use the debugging tools and often some testing tools also. There are several reasons for the presence of multiple routing instances in the network. Networks evolve dynamically. Oftentimes, networks running the IGPS have to be confirmed to form a larger network. Each routing instance is assigned as an administrative distance at each border node. For every destination, the border node elects the route computed from within which the routing distance having the smallest administrative distance, which sends the data to the destination using the routing protocol. So now let's see about the proposed system. The main contribution of this paper is what we call as automatic test package generation. ATPG framework that automatically generates a minimal set of packets to test the liveness of the underlying topology and the configuration between the data plain set and the configuration specifications. Test packets are sent periodically and detected failures trigger a separate mechanism to localize the fault. ATPG can detect both functional and performance problems. ATPG detects the incorrect firewall and congested queue, which occurs in performance problems. A widely used alternative to interconnect routing instances relies on the twin mechanisms of route election and route redistribution. This is developed by routing protocol. Then now let's see about its advantages. ATPG treats router configuration and generates a device-independent model, the new form of interconnection that overcomes the limitations of route election and route redistribution, which permits the configuration of a resistant and efficient routing system. ATPG use cases for both functional and performance testing. So these are the advantages of this project. Now let's see about its system configurations. So the hardware and software requirements will be like this. And my front end is in Java and my back end is MySQL. So now let's see how to run my project. NetBeans application where I'm going to run my project. So here I have saved my file name as singlepath and homepage.java, which I'm going to run here. So my home page looks like this. I have created over here two buttons, single path and multipath. So when I click on single path, it takes me to single path page over here. So I'm going to run this to generate the number of nodes. So now I'm going to enter the number of nodes over here as 10. So when I click on node, it will generate 10 nodes over here. So I'm going to enter the starting node as 2 and the destination node as 7. Now it's going to display the single path over here from 2 to 7, as you can see here. So when I click on node failure, it will show the node failure at 7. So now we are going to multipath to generate the multiple paths over here. So when you click on grid, it will display the number of rows and columns. So now I'm going to click on review. It will not show any lines over here. So this will make easier to view the lines. So here enter the number of nodes as 10 and then click on install. It will install 10 nodes over here. When you click on multiple path, it will generate all the multiple paths over here. So this is the administrative distance at every border node, which displays the starting node from each other destination. So here enter the foundation way as 2 and the intention way as 7. So it reach the way, you can see over here from 2 to 1 and 1 to 9 and 3, it's showing the passageway way here in this dark line. So I'm going to select the file location over here as run the file. So when you click on present, it's going to show the present file over here, and when you click on location, it will display the location over here, the location of nodes. And when you click on distance, it's going to show the distance of the nodes. So when you click on encrypt, it will show the encrypted messages over here, as you can see here. And now my aim of the project is to generate the minimum number of packets. So here you can see the minimum number of packets has been generated, and when you click on node collapse, it will take me to node failure page, the shortest path which you are going to get displayed. So enter the number of nodes as 10 over here. 10 nodes will be getting generated, and enter the starting node as 2 and the destination stored as 8. Click on path, it will show the path from 2 to 8, from 2 to 4 and 4 to 3 and 3 to 8. So this is the shortest path over here. So if you want to check the node failure where it has been occurred, just click on node failure. It will show the node failure at the source too. So when you click on alternative node, it will show over here in yellow color. So when you click on alternative path, it will generate the path from this alternative node to the destination, which travels through 4 to 3 and 3 to 8. So this is how the project runs to display the shortest path, and it pre-elects the redistributed path over here. So when you click on decrypt, it will show the decrypted messages which has got encrypted from collaborative path location. Thank you for the valuable time.